I would say hi, people, but I can't see you anymore.
Yeah.
So, welcome to the session this afternoon. Thank you very much for attending it. I know it's late in the week and people are not over-information fed yet. My name is Cobus Bernard. I'm a senior developer advocate at AWS.
I'm Julia. I'm an AWS container hero. I'm a CNCF ambassador, and I'm also a global technologist at Vim. And you're going to share the agenda with everyone, right?
Yeah. Well, there we go. So basically, we're just going to keep the agenda overview short. First, we're going to go over some basically ways you can manage your containers on AWS, because there's a bunch of different ways and trade-offs, and have to think about that. Then we're going to go over a list of the service groupings to kind of create this mental model of how to think about the services together, because just because you can run a container doesn't mean it's exactly the same way that you may want to think about it and what the trade-offs are. And then the demo portion is somewhat misnamed. Initially, we had a plan to have lots of demos running here, and then we started looking at all the different use cases and realized that there's no way we can show you all of those. So we will cover a chunk in that demo section, but there will also be some resources that we'll share afterwards. And with that, Julia.
Yeah. So imagine you just woke up, had your breakfast, and you have to make a big decision today. You have to decide which container service you're going to use to run your application on AWS. And your team is waiting for you to make that decision. Management is asking questions. And you don't know which service to use. Probably I've been there. Probably you all are in that situation. Or you're curious about the different AWS container services. And you don't know if you want to, you need to prioritize something. Maybe you want flexibility for different types of workloads, or you want agility. You know, you probably are like this guy, or you want to save on costs, still, running containers on AWS. There is always a trade-off with the decision that you make. And the goal of our talk is to help you, with the decision-making and show you what's better for each situation. And yes. And this quote is a little confusing, so you can do anything but not everything, by David Allen. And what does this mean? It means the cloud gives you endless possibilities, to run containers and a lot of services. AWS has hundreds and hundreds of not only container services, but general services for other things as well. And again, what you need here is to know what you want to do. So AWS can help you, but it depends on your needs, on the level of expertise of your team, on the challenges that you're facing, and everything has a trade-off. So if you choose one service, you're gonna lose somewhere. And that's why you can do anything but not everything. You have to always pick something, make the decision. And it's hard because you worry, oh, maybe am I going to regret after, etc. That's why you really have to think about it before making any decisions. So Cobus will go over the layers of the stack and a little bit of the shared responsibility model before we start talking about the services.
Okay, before we get into that, can I get a quick show of hands? Who's running containers in production at the moment? Okay, for those watching remotely, about half the audience. Who of those are running with Amazon ECS? Okay, about half of that. EKS, also about half of that. Any other permutations? AppRunner? Yeah, some AppRunners. Lightsail? Okay, awesome. So I've at least got one thing to talk about today. Okay, so let me grab water before we get into the stacks. So, sorry. Some of you may have seen this diagram before, but if you think about running a container, there's a whole bunch of things that you need to take into account. It's effectively, here's my container that's running my code, and then what does it run on? The thing that it runs on, you may need to maintain, like let's say it's an EC2 instance, or if you're self-hosting your container. So you have to worry about the operating system down below or under it as well. And then the deployment pipeline, the build and the deployment pipeline, how you're going to orchestrate those changes and all of those things. So if we start looking at the stack in terms of the different ways you can do that, this is an example of running a container directly on EC2 where effectively, other than the physical hardware, you manage everything yourself. You have to set up, let's say, the networking, the pipeline, all of those bits. And then as you start progressing up the stack, You can, sorry, the previous one. Let me see, can I go back? Come on. No.
Usually.
Oh, okay. The previous one. So what I said is the previous one was actually a physical server that you manage yourself. Now, I personally have a rack for the first time at home, so I'm a box hacker. So I run my containers on bare metal at home, which is a lot of fun for me, but I would definitely not do that for production, for any kind of business. It's way too much effort. I just do it because it's a lot of fun. So EC2, you don't have to worry about the hardware anymore. AWS takes care of that for you. And then when we start looking at how you actually manage the orchestration, you can then, instead of making sure that your container is running with whatever mechanism you have on that EC2 host, you can use Amazon ECS. And that basically provides the orchestration framework for you. Now, fun little side note here quickly. I think it's about 10 years ago at this point, ECS was already out, and I was working with a startup with containers. And at that point, and that was long before I joined AWS, I was like, I don't need this. I'm going to write it myself. So guess what I did? Bash scripts. And who can guess how well that worked and for how long? So fun fact that I learned that day is if you get an error exit code that's above 128, it means that a child process actually killed the parent process in Linux. How do I know this? Because I had this fancy regex to actually find the container, to stop it, because if it didn't stop in time, our workload allowed us to then just kill off the process and then restart. And then someone decided to name a container similar to the actual process that I had named my bash file, so yes. Fun fact, what's the plural of regex? Regrets. Ask me how I know. Okay, so moving along. Similarly, to, with EKS, you can use EC2 instances to actually provide all your capacity to run your containers on, and then EKS provides the orchestration to basically run them and manage the life cycle of the containers, deploy them, all of those fun things for you. But there's still the underlying OS. It doesn't magically go away. There's an operating system you need to maintain, patch, monitor, and think about how it is actually operating and running. Then if we move up a little bit more with AWS Fargate, this is where you don't have the actual instance to worry about. You basically specify how much RAM and CPU with the combinations that are available that you can pick, and then you say, here's my container, let's go and run it. But inside the container, you still have to worry about the actual runtime. We'll touch a little bit on that in a later slide about what goes into that little box. But basically, the amount that you have to worry about is a lot less. So it makes it a bit easier to actually run your containers. Then, similarly, you can use EKS with Fargate as well, which means you don't have to worry about, let's say, bin packing and how much capacity the host has, resource contention on the host, etc. So that also starts simplifying a lot. And same as with the previous slide with the ECS version of this, there's no host that you have to actually maintain, patch, and keep going. And then lastly, if you look at AWS App Runner, this is where you can really start focusing just on the app. Now, there are two ways you can approach the App Runner implementation of running your container. The first is you can basically take a container and provide it to App Runner and say, here's my container, go run it. You still, in that case, need to worry what goes inside the container because you're responsible for the runtime, configuration of it, getting the right source files or compiled files in there, and making sure the actual container is configured correctly. Or what you can do is basically connect App Runner to your source code repository. There's a long list of languages that it supports, Java, Python, Go, Rust. Actually, I think fairly certain about Rust, but basically what it means is it can see, oh, it's this language, detects it, and then actually does the build and packaging into the container for you, and then goes and runs that container for you. So at the end of the day, what you're focusing on there is basically writing the code for your application, not necessarily worrying about the service, the patching, the runtime in the container, etc., which makes it a bit easier. And now we're going to take a look at how we group these services.
Yeah, thank you. So I like to say that using AWS is like playing with Legos. You can choose to buy already something fully assembled, a Lego set, or you can assemble it yourself. And to understand the container services, I split them into three groups. So the first group is you bring your container image, you pull it from ECR or another container registry, and AWS runs it for you. So that's, and here you have some services like ECS, EKS, App Runner for web development, and Lambda for more specific use cases. And they all offer different levels of flexibility. Now, the second group bucket that we have is like Cobus mentioned, you can still bring your container image, but usually you pick those services for the added value that it brings. So you have a specific need, and you use those services, and you can still run containers, but that's not, the main goal here. And services for that, again, App Runner, AWS Amplify that helps build mobile and front-end applications. Also, it provides features like authentication, hosting, and back-end integrations. Also, we have AWS Elastic Beanstalk that helps deploying and managing web applications as well, and it automatically handles the infrastructure provisioning and scaling and all the updatings for you. Now, the third bucket here is when the containers are running under the hood. So you don't even see them because AWS manages them for you. They take away all that complexity. You don't have to run the infrastructure. And a lot of the AWS services are using this model now because they want to help make development faster and more friendly. So there are a few services, and what's confusing here is that some services, they overlap on 2 or even 3 of the buckets, like we see App Runner. So this can cause some confusion in understanding the exact role of each service and how they run the containers. To do that, we're going to focus on the first 2 buckets, because these first 2 buckets, they answer how can we run my container image or my code packaged into a container. The third one, it's behind the scenes. We can't manage that. To go a little bit deeper, we're going to talk about the layers. So the layers that make up container management. At the bottom, as you can see, we have the capacity layer. So it's like the foundation. It's the engine that provides the raw computing power. So CPU, memory, and the infrastructure resources. It ensures every container have the resources you need to run an application reliably. Now, the second layer is the orchestration layer, and it's similar to a traffic controller. So it manages how containers are deployed and scaled across your environment. So let's say you want to run 1,000 containers across 20 EC2 instances. The orchestration layer is going to help you with that and make sure that it has the resources and they are split evenly among all the instances. And the third layer is the provisioning layer. It helps and simplifies the interaction with the orchestrator. So it reduces friction for developers. They don't have to, define deployment configurations, manage CI/CD pipelines, or because the resources are provisioned automatically for them. Again, helping them abstracting the complexity so they can focus on the business logic and writing the code. But what does this mean, these 3 layers? What do they mean in terms of AWS services? So let's look at the layers again, but now we're going to put some services there. At the bottom, again, the capacity layer, we have Amazon EC2 and AWS Fargate. So EC2 is, those virtual machines that we know. You have full control over the instance configuration. You can fine-tune compute, memory, networking, everything for your containerized applications. And AWS Fargate is your serverless compute option. So it abstracts the infrastructure entirely, and with that, everything is automated for you based on your container's definitions. Now, the next layer, the orchestration layer, we have a few services. AWS provides a few orchestrators. So first, we have Amazon ECS, which is a lightweight AWS native orchestrator that is tightly integrated with the AWS ecosystem. So you can use all the AWS services with Amazon ECS. Then we have Amazon EKS, which is a fully managed Kubernetes service. So it runs vanilla Kubernetes, and it allows you to leverage Kubernetes on AWS. And you can use, the CNCF open source projects. With those, it also connects with a few AWS services. We're gonna go through that, like what you can use to extend EKS. Then the third orchestrator is ROSA, so Red Hat OpenShift service on AWS, which is a co-managed service between Red Hat and AWS, mostly designed for hybrid and multi-cloud environments. And now also with Amazon EKS Anywhere and Amazon ECS Anywhere, you're not tied to AWS regions anymore. You can run containers on premises in your data centers. So it extends the orchestration to, even edge environments if you have those as well. And then the third layer is the provisioning layer. So it really abstracts that interaction with the orchestration and makes container deployment development friendly. So we have AppRunner, Elastic Beanstalk, Amplify, and Lightsail, and they're very specific. We'll go over them, but these are how the services are categorized. Now there is another one here, and it's a bit unique, a wild card, I say, because it doesn't fit in any of these three layers, but it actually encompasses these three layers in itself. Because the capacity, first, it provisions compute resources automatically for you. Then Lambda also has that orchestration part because it manages the life cycle of your code execution, also handles scaling, and automatically retrials failed executions. And then it has the provisioning because it provides a simple event-driven interface. So you just upload your code or your container image, you set up a trigger, and then Lambda takes care of the rest for you. A lot of people, they say serverless versus Kubernetes. You can use both. So we'll go over each service in a little bit. We have a lot of options we see here. But we put this yellow dot on all the containers that you can run, all the services that you can run containers on AWS. And you might notice that we haven't put a yellow dot on one of these services. And people say, okay, but I'm using Fargate to run containers on AWS. Why isn't it considered a way to run containers? The explanation is that, yes, you can, AWS Fargate is a compute option, but it's not a standalone service for running containers on AWS. You have to use an orchestrator like Amazon ECS or EKS to use Fargate. And the infrastructure exists in your AWS account, so you can see the logs, you can see costs, metrics, but it's abstracted through the orchestrator. Now, it's gonna get a little bit confusing with the colors and icons, but here, the pink triangle are the services where you can interact with the infrastructure in your AWS account. So you directly manage the infrastructure components, so compute, networking, or other orchestration settings. And these services are good if you need fine-grained control over, how you're gonna run your container. But obviously, they require more management and setting up these services. So here, the trade-off is you have more control, but the control comes with complexity. Now, these other services that have the green diamond, these services, you don't manage the infrastructure. So in the provisioning layer, AWS handles that for you. You don't have, everything is abstracted, the underlying infrastructure. And this is good for teams, people that don't want to manage servers or orchestration. You know, they just want to use a service for whatever use case they need, get up their application up and running, and they don't want to manage everything else. So the trade-off here is it's easy to use, but you don't get that flexibility that we're going to talk about. Now, when teams, organizations, they decide on which container service to use on AWS, usually they follow two approaches. So the first approach is more tactical, we would say, so fit-for-purpose solution. And this approach focuses mostly on the provisioning layer because the conversation is driven by practical solutions to get the application up and running quickly. And they don't want to think about the infrastructure and having to manage everything. So usually it's, you know, startups or smaller teams that have a specific use case, they will use one of these services. And normally they don't take into account, you know, broader organizational impact or long-term goals when deciding on the services. On the other hand, the more strategic approach focuses on organizational level discussions because typically this is a team that is building a platform to help developers deploy their containerized applications, and they want to standardize the deployment across the whole company. So usually, you know, it's a bigger team compared to the provisioning, the tactical approach that we just talked about. And here they balance long-term needs like scalability, control, and the developer experience as well, and also the in-house experience, the expertise that the platform team has. So these decisions, they are more impactful than the tactical ones, and they require more operational expertise to run these services, to manage the orchestrators. Now, Cobus will go over a few options that you have if you want to optimize for cost, so the container services for cost.
Awesome, thanks. So I'm assuming most people would like to know how to reduce the costs, so actually focus on that. Just out of interest, is there anyone here where there's no limit on what you can spend on your AWS account?
We wish.
If there is.
In another lifetime.
Yeah, okay. So let's take a look here. So starting off, if you compare and look at Amazon EC2 versus Amazon Lightsail, the big difference there to figure out your cost breakdown is that Lightsail has a fixed per month cost regardless of how many days in the month there are, where with EC2 it's per second billing, which means that depending exactly on how the month or how long the month is, that cost can basically fluctuate over time during the month. So it's still fully manageable in terms of like being able to calculate upfront how much it is going to cost you to run these, unless you've got, let's say, auto-scaling going and things go up and down, or in terms of the capacity that you're running. But that's one way to think about it. And effectively, you have to manage that yourself to figure out what is your budget going to be with the instances that you're running. Now, we touched earlier on the difference between effectively bare metal or just a virtual machine and then you doing everything on there, preferably without bash scripts. Where with ECS, you can use that in combination with EC2, but ECS itself does not incur any cost. So you can create a cluster. At that point, until you add compute capacity to your cluster, there's no extra cost involved in it. So it's a much better way, I would say, if you do want to use virtual machines to actually run them. You can't combine ECS with Lightsail when you're using Lightsail to run containers. So just a quick clarification there, Lightsail comes in effectively two flavors, if you can think about it that way. The one is a VPS or a virtual private server. You basically spin it, pick the size that you want based on RAM and network throughput and compute capacity, and then it basically spins up, and then you can go and install whatever you want on there. The other option is to run it with containers specifically. In that case, you don't have direct access to the host itself, but you actually do a container deployment onto the host. So in theory, and I actually want to go try this because I'm not very curious since I didn't think about this beforehand, but I don't think there's anything stopping you from installing the ECS agent on a Lightsail instance and then using Lightsail with ECS. I wouldn't recommend it, but in theory it could be possible. So that could be a fun one to go look at. This one was actually very interesting to me because I've been using Lambda functions for a couple of years on multiple different projects, and I knew about the fact that you could use a container with it, but it can actually simplify things quite a lot. And I've got a detailed costing example later on for you as well to just showcase why this might be a good example. But like we mentioned earlier in the talk, there will always be some trade-offs here in terms of what you get by picking one of the options. But you can build a Lambda container. It's slightly different to building your normal container because you have to use one of the base images provided so that your language runtime is in there, similar to how it would be if you just provided the code for your Lambda function itself without a container. And then from there, basically, you can run it. The other important limitation there to know about, which you can run into, can't run into, depending on what type of language you're using, is that with a Lambda function, there's a 50 megabyte limit to the actual package that you upload. And once uploaded, when it uncompresses, so the zip file 50 megabytes, and when it's uncompressed, 250 megabytes. Whereas with containers, you can upload a container that when it's uncompressed, in other words, all the different layers are basically expanded on the host. That can be up to 10 gigabytes. So there's quite a big difference there. Personally, I ran into this when I did a migration from a .NET 6 to a .NET 8 Lambda application. And I didn't bother to clean up the project after the migration, and then it had a whole bunch of NuGet packages installed by default that I didn't end up needing. So that's something to think about when you are considering how to run and optimize the cost. Because the longer it takes to upload, obviously, the longer your new release might take to get out. So, talking about cost optimization, who's used Amazon Spot instances or Fargate Spot? Okay, we've got a couple of folks here. They released this, I want to say, I can't put a date on it, but it was definitely a couple of years ago, and this was something that I really loved, because personally, once again, before joining AWS, I worked with a bunch of startups doing consulting, helping them optimize the usage of AWS, cost optimization, as well as like how much time it took the developers to actually build and ship different services. And before, what would happen is you would have to pick a Spot instance type that you want to use. So let's say a DEV3 medium instance. And you would say, okay, cool, I want a Spot instance of that. And then you would use it, and you get if let's say they needed the capacity, you would get the notification, and you had to manually figure out what to do when that instance went down. And if you then want to use, let's say, a different instance family, it was, okay, let's go reconfigure things and swap it out. Where now what you can actually do is you can define a whole set of instances with weights. So what you can see over here is there's a lot of rich data. So you can also see what the current price is based on the spot, because the spot price fluctuates. So some instances may be a lot cheaper at the moment because there's very low demand, and it also differs between the different regions. Whereas with other ones, there might be high demand, etc. But you can then, in short, define these are the different family and instance types I want, and then you can also put a weighting to them, because as we know, the different instances have different sizes. So you can literally go M5 large has got a weight of 1, then an M5 XL, which is usually double the resource capacity, you can give a weight of 2, and then it can figure out what you want in terms of the scaling. So think about that when you run your containers. And then similarly for Fargate, you can also use Spot instances. I did a quick check this morning. The Spot instances are it's a bit more than a quarter of the price of a quarter of the full price of Fargate are the Spot prices, but it's slightly above that quarter, so it's 1 point whatever. I didn't do the math, sorry. But what that boils down to, and why this is important, is when you think about your workloads, always think about my capacity for how much do I need to always be on versus do I have like a burst, like a batch processing that I can offload to a Spot instance, because if that Spot instance does have to be taken away and the process didn't complete, is it a process I can redo? Because if you think about it, at about a quarter of the cost, I can run that same process 4 times. And unless there's huge capacity issues, that shouldn't be a problem. So think about that when you're thinking about your cost optimization approach with regards to building the different instances. There we go. So optimizing to reduce the cost complexity and operational efforts.
So if you're looking to optimize the complexity, you're going to have to pay more. So one of the services that you can use is AWS App Runner. It abstracts, I've been telling you, those 3 layers. App Runner is on the top layer. It really abstracts away nearly all the operational complexity and handles scaling, load balancing, and updates automatically for you. The trade-off here is you have a lot of simplicity, but it comes with a higher cost. Now, another option would be also to use Amazon ECS with AWS Fargate. It's similar to App Runner, so you're gonna have to pay a little bit more, but with Fargate, you can define the task definition and AWS will handle the scaling and provisioning for you. So this combination is pretty powerful. You can run a lot of containerized workloads, most of them with this combination. But again, it comes with a higher price point compared to using EC2, managing EC2 directly, which we're gonna talk on the next slide. And you pay a premium for this, you know, for the reduced complexity, for the convenience that you have using Fargate, this serverless compute. Now, the third option would be to use Amazon EC2 Fleet. So here, you have complete control over the underlying compute resource. So, but what does that mean? It means you have to manage the EC2 instances, scaling, and updates. With EC2, you can also balance cost and performance. So for instance, we were talking about Spot, but you can use saving plans or reserved EC2 instances to lock in lower costs for consistent or predictable workloads. And then you can also use Spot Fargate or Spot EC2 instances to handle traffic spikes or dynamic workloads like fault-tolerant, flexible tasks like batch jobs, CI/CD pipelines, etc. And they save up to 90% of costs compared to on-demand EC2 instances. Now, if you want to optimize for flexibility or scalability, so if you want to ensure your workloads can vary depending on different needs and they can seamlessly grow depending on the demand, you will have to use something else. So Amazon EKS with Amazon EC2. EKS brings you the power of Kubernetes. So it brings all the Kubernetes native features with the reliability and simplicity of AWS. So it's a perfect service for that if you need that power of Kubernetes. And EKS handles basically the foundational aspect of Kubernetes, like dealing and managing the control plane, applying security patches, and ensuring high availability of the Kubernetes API. But at the same time, you have control on how to configure the networking, storage, and access policies for your applications. Also, EKS is highly modular. You can use AWS services, and you can use, all the open source projects from the CNCF. They have a huge ecosystem and a lot of tools that work very well with EKS. Here, the trade-off, I would say, is you get that flexibility, but EKS can be hard to set up and maintain. So this is a thing. I really like Kubernetes, but I tell people it's not for every use case. Companies, they hear the buzzword Kubernetes and they say implement Kubernetes, but a lot of times it's not the best for you. It depends, and you really have to think: is this what we really need? Probably it won't be. But that's not it. This is topic for another talk. Now, EKS with EC2 gives you that full control over the underlying compute infrastructure. So, all the node configuration, scaling policies, and workload isolation. And similar with EKS that I was talking about EC2, you can also tune the performance and the costs. So you can leverage tools like saving plans for predictable workloads and Spot instances for cost-efficient scaling during traffic spikes. Now, another option is to use Amazon EKS with AWS Fargate, which is the serverless compute option. And here, you don't have any nodes or EC2 instances to manage. AWS does all of that for you, so handles all the underlying infrastructure, provisioning, upgrades, patches, and other maintenance tasks. Now, you get simplified scaling here, so you essentially have access to unlimited compute resources while AWS dynamically scales that for you, the infrastructure behind the scenes, depending on your pod requirement. You also can right-size your workload, so depending on the pricing model that you're using in Fargate, these will be based in a pre-configured CPU or memory combinations, and these will make it easier to match resources to your workload-specific needs. And it also helps with secure isolation. There are a lot of things that Fargate can bring, but again, it comes with a higher cost compared to the EC2 instances. On Sunday, I believe Sunday was December 1st. I'm already lost in the week.
Yes.
But there was a new feature released, so Amazon EKS Auto Mode, and it pretty much simplifies the EKS management by automating the node provisioning, scaling, and patching. So what I just said about EKS with EC2, this makes it even easier. So it really abstracts away. You still have the EC2 instances behind the scene, but the management is automated by AWS. And also, it's best for workloads that require the flexibility from different EC2 instances, and when you also need control over the type and configuration of the EC2 instance. So now I think it's the best of both worlds. You get EKS with EC2, but it's managed for you by AWS. Now, if you want to extend and use even more services and have more features with EKS, there are several extensions. So you can install some tools as a standalone component through Helm charts, but AWS makes it even easier for you. So there are some add-ons that come already with your cluster when you install it. There are also add-ons from independent software vendors. A lot of vendors, they already created that, so you don't even need to install. It comes with the EKS cluster. There are AWS controllers for Kubernetes, ACK, so that helps you interact with AWS services easier. So, you know, S3 buckets, if you want to use S3, or if you want to use an RDS database, the ACK can help you with that. There are Amazon EKS blueprints for CDK or Terraform. So they offer ready-to-use templates for deploying tools in an easier way and for production-ready deployments. There is also Amazon Managed Prometheus and Grafana if you need more observability. And Carpenter optimizes the resource utilization by dynamically handling and scaling nodes based on workload demands. Now, I put this together because, again, I said I'm a CNCF ambassador. I use a lot of the open source tools there, but you can also use AWS services. So this is it's a little comparison of, you know, AWS managed services and standalone CNCF open source tools. And yeah, if you need, you can change. But I think this is good when you're using AWS. Now, Cobus will start the demo, right?
The demo.
A new demo.
Yes. Yeah. Okay. So like I mentioned earlier, the challenge that I faced when we were working on this to get the demo is we were thinking about, okay, we've got about, at the moment, we've got 22 minutes and 19 seconds left. How do I show you how to run containers on anything but Kubernetes? And Julia can show you Kubernetes. I've used it, I understand it. I haven't used it fully in production, so I don't feel comfortable trying to explain how to use it in production, because you should definitely not trust me then. So what we're going to do is we're going to have a bit of a chat now about how to think about how to start running your containers. So the first thing is, let's figure out like where you are on the spectrum of experience with containers, because some people might have no experience with a container, and that's fine. It's something new, awesome, new toy to play with. Or you could have been running it for years and years, and you run like massive systems across lots of different regions, etc. Another angle on this, if you think about the dimension, is like not every business has got the need to have the app running every single second of the day. And also when you're thinking about deployments, because I'm old enough to come before Git, before Docker, and I think it was still called Hudson. It wasn't even called Jenkins then. So back in those days, we did have maintenance windows. We did try and get it down to about 2-3 seconds, but it was a very well-oiled, coordinated deployment machine because we simply didn't have the tools to be able to do it. But in the context of the systems we were running, that 2-second outage was perfectly fine because the request would just wait a bit, and then when the instance came back up again, it would actually service that request. So always think about how much complexity you want to build into your system, because do you really need all of this, let's say, not dropping a single request, or managing, for example, if the process is still running, do you actually have to wait for that process to complete, or is it perfectly fine for you to, let's say, terminate that instance and just switch over to the new one? So think about that when you want to run it. Because remember, as we said earlier, you can do anything, but you can't do everything. So you're going to have to figure out what the trade-offs are for you. So touching quickly just on Docker, this is not supposed to be readable, but that's just a quick bit from a build spec file on how to build a container. So if we were to convert this into slightly easier to understand English, it's basically the steps to create a container. Now, this is where you need to figure out what goes into that container. So at this point, we're assuming you're going to be starting from a Docker file definition that has at least the basic runtime in it for you to be able to run and possibly compile your source code, because it depends on what language you're using. Now, you can get a lot more fancy on this level, saying the first level is, okay, let's just make sure we can compile and then save the artifact, or if we need to install dependencies like for a runtime, or sorry, a scripted language like Python or JavaScript, you install those inside the container and off you go. If you want to optimize more, you can start looking at multi-container builds where you've got a specific container image that you use for building, and then once you've got the artifacts that you need, whether it's a compiled binary or the downloaded resources for that runtime language, you can then put inside, and then you can also obviously go multi-architecture as well, where you compile both for x86 as well as ARM64. But that depends on what your use case is, to just compile and get it inside the box. Now, I'm going to look at a couple of pricing examples for you just to give a feel, and then we're going to talk about the trade-offs with those different options that you can take. So just to clarify first, I grabbed the pricing for the US East 1 region based on the ones that you'll see. Amazon documentation by default uses 750 hours because it's a nice round number, even though it's more than the longest month in the year. So I just want to point that out when you look at the math and go like, that's more than a month. And then also, with the different services, there are a bunch of services that have different levels of free tier available to new accounts. Some of them are the first 12 months, some of them are forever free, some of them are different dimensions. So I'm not going to touch too much on that, but definitely go look at that. I do call out one of those there that I feel is important. So optimizing for cost. Let's first figure out what is cost. I'm assuming most of you would agree this is, what the cost is that we need to think about when we're optimizing, right? Anybody disagree? Okay, trick question. Did you factor in the cost of the developers maintaining things? So I did a quick search on the internet what the average software developer salary in the US is, and as we know, the internet is always right. So the first hit said $132,000 on average. Found a little bit about that. I think that's odd, but let's use that. So if you take that number and you work 5 days a week because you never take any PTO, what is your hourly rate? That turns out to be about $68. So when you start thinking about the cost of running a service over a month, also factor in how much does it cost actually for the developer in terms of their time. Then there's obviously the business cost, because if your servers are down, let's say you're an online store like, I don't know, what's a good example of an online store selling thing that needs to be up all the time? Basically, if the store is down, you're not selling products, which means there's a business impact in terms of the cost of what it takes to actually run the services, and also adapting to the market. And then you've got the fun joy of a single point of failure, and this is both the system as well as the people. Because this is something a lot of folks don't think about, is if you're running at a company and you've got, like I have in the past, very stupidly, built awesome bash scripts. They are arcane, but they do awesome things, according to me at least, and I'm the only one that can run them. I'm the only one that can fix them. What's going to happen to the company if I, for whatever reason, leave or don't work there anymore? So think about that cost also. When you start thinking about the total cost of running whatever container-based workload you want to do, it's not just about the, hey, what's the infrastructure cost, but it's everything else that goes with that you need to take into account. So let's look at some example cost. If we're starting with just an EC2 instance, and I basically picked the smallest instance that I could find, which is the T3A Nano, which comes with 2 virtual CPUs and half a gigabyte of memory. Just an important note here, because you'll see when we compare with the ones after this, there I start looking at a quarter virtual CPU, but also a half gig of RAM, is that the T family is burstable, which means you start off with a certain amount of CPU credits. So, and then as you spike your CPU, it basically eats into those credits. So you have to figure out like what your workload is and how quickly you'll run out of those credits or not. Because when the server is idling again, then you start building up credits again. And that's very useful for spiky workloads because the instances themselves are a lot cheaper because of that and the way you can use them. So you can see here it works out to about $3.50 a month to run a Nano instance, and then you can either use, let's say, Amazon ECS with that, because honestly, at this point, I would not try and run containers by hand anymore, like bash commands or whatever thing. I would use some kind of orchestrator. So that's what it basically costs. Then you can implement automated scaling for that, but things you have to think about then that you want to maybe either run yourself or use some of the AWS managed services is patching the servers, maintaining them, keeping an eye on that server load, because that will take time out of your development cycles to be able to actually make sure that this is working. And then also, do you want to self-manage your load balancing and your SSL certificate? So that's what you can basically do. Obviously, there are services that you can add on to it, but this is the bare minimum if you want to run like just one instance to actually run it. The next up, I've got the Amazon Lightsail instance. So this one is a fixed cost of $7 per month. You can see this now where the CPU differences changes because this is not a burstable instance. This is you get that quarter CPU for the whole month and half a gig of RAM. In this instance, because it's using the container version of Lightsail, you don't have to worry about patching or maintaining that host. That's all taken care of under the hood for you. But then you still have to figure out how you're going to load balance, because you can think about, okay, I've got one instance over here. There's no auto-scaling available at the moment, so you would have to go and run some kind of command to say, okay, cool, now launch a second one, launch a third one. And then if you don't have the load balancer that Lightsail offers, you would need to figure out how you handle those DNS entries with a reverse proxy or something at the top. So you need to figure out how you want to handle the self-scaling, which also takes time, but doesn't show up on your AWS bill. Then you can go up the stack a little bit more, just under $10, you can use Amazon ECS with Fargate. And that actually is where you start getting to the point where there's not a lot of maintenance for you. It's effectively you starting to focus more and more just on what's in my Docker container and what code am I running and what features that I want to roll out there. Automated scaling, and this is where you can also implement a split between the Fargate and the Fargate spot instances, because you can actually set up a ratio to say how many per, let's say, Fargate instance, how many of the spot instances you want, if you want to balance it out that way. So it's also a useful way to actually reduce the cost further. Similar as before, I'm basically pretending that the load balancers don't exist, just to show you, because they obviously add an extra cost onto the per month running, but this is if you want to run it yourself and how to do it. Then App Runner. This is where things become a little bit interesting, because the load balancer is actually built into the monthly or the per second costing of App Runner. So you can use the load balancer and you can add your own domain even with Amazon's certificate manager for a custom domain in there with and not have to go purchase this SSL certificate and deal with the fun of installing that and managing that. So there, but this is now coming up at $17.25, and this is assuming you have got your single container running the whole month. You can configure App Runner to basically switch down to 0, or you can even switch it off for certain time periods, but it depends on what kind of application you're running. So you can, that's if it's running 24/7 for a month, that is 31.25 days long. So you can see here, and once again, think back about that cost about developer time per hour, and that's just one metric about that. So it makes it a lot easier then to basically just focus on the code. And then my favorite one, at the moment at least, is if you think about using the containers with Lambda. Because Lambda comes with a forever free tier, it's effectively allows you to run up to 1 million requests per month, and then the subgrouping there with 500 gigabyte seconds and 32 million seconds of compute time, because Lambda uses a matrix of the amount of compute with the amount of RAM and then the duration that it runs that you can get. Now, you can call a Lambda function directly with a feature that was released earlier this year with doing HTTP calls directly to it. But generally speaking, I'm assuming you don't want just your API open completely to the internet without anything in front of it. So that's why I added in the cost for API gateway with some samples there of the two different ways, HTTP and REST APIs to call them, and what the costing per month is for that. But you can see you can probably get an API running on Lambda for very low cost. So that's probably, if you're asking me to optimize like to the extreme, this is probably what will work. Now, with this, when you scale to past a certain side, you'll need to keep an eye on how much the Lambda cost would be versus, let's say, a dedicated EC2 instance or Fargate running the whole time and balancing that out. Now, when do you start figuring out when to change between the different implementations? Because unless you've got a lot of experience, you're probably going to run into a situation where you went one route and then halfway through to realize, or at the end realize, maybe we should have picked something else. So these are just very high-level like guidances to give you. The one that I found with Lightsail is effectively you can have up to 10 individual container definitions inside a single deployment that you make onto your Lightsail instance, which means if you need 11, that's clearly a limit that you'll have to think about. The other part to think about is the deployment flow. It does do green-blue deployment as most of the services that we've mentioned here today. But if you have, for example, 2 repositories, app 1 and app 2, and you've got 2 build pipelines, if you then want to deploy to your Lightsail instance, what will happen is on every deploy, depending on which side, it doesn't matter which side triggered it, it'll redeploy both those containers as part of the next deployment. So just keep that in mind. It might not be the ideal setup for everyone because let's say you do want to keep some kind of state in memory inside your container as long as possible while it's running. That might not be the ideal one. Then when we're looking at ECS and EC2, this is kind of where the guidance comes around. Do you want to still continue maintaining your servers and patching them and running them? Where I would start looking at Fargate rather, because then you take that operational load off. Now, as someone who used to run a lot of servers with Chef, I think I peaked at about 180. The startup was just getting going. That was a lot of fun. I enjoyed it. I felt very happy. I trained up 2 other people in the DevOps team to be able to use it. And then we got to a point where we realized, as awesome as this is, do you know what's even more awesome? Just building a new EC2 image once a weekend with whatever new patching we want to do, and then using autoscaling to roll that image out instead of having to worry about Chef and the recipes and making sure we do version pinning and not having the wrong thing. So it was great for me. I felt super smart, but simple is often a lot better. So try and simplify how much you manage. And then with ECS and Fargate, you might get to the point where you feel that even that is too complex. Let's just go over to AppRunner because I can provide my code and it'll just run it for me. And that's all I want to care about. I just want to write code and basically have the code running. So just remember, when we're thinking about the code in terms of, or the cost of running these containers, there's not just the raw cost about what is actually running on and shows up in your AWS build. There's a lot more cost involved in that as well. And now, just to round it off, that is a QR code to go to the short link there at the bottom. It's a post on community.aws where we'll be embedding this video of the recording as well as sharing the whole code repo. So I should be able to get, well, I'll already publish some of that next week when I get back from reInvent. But effectively what we did is we built some examples using Lightsail, AppRunner, ECS with EC2 and Fargate. We'll see if we can get EKS in there. And by we, I mean Julia, but we'll see. And then also it's provided with, I'm providing Terraform versions, and then we're also doing some CDK versions. So you can pick and play and basically use that to decide which of the infrastructure setups you want to spin up to take a look at what does it take to actually get that container up and running. And with that, thank you. Julia, thank you.
Thank you.